All right, so I'm just going to go through the rest of the third page on our Paperclipium and matter worksheet. We did the first 2 pages together, and then I'll do about 3 or 4 example problems that are from the note sheet that are actually the same on here. So I'll do the first 4 of the chart down below, and then you can kind of do the rest on your own and kind of check yourself there. So in terms of the vocab of this unit, we learned a lot about the different classifications of matter last class and different vocabulary terms. And so I kind of have these all here as a little one-stop shop so that you don't necessarily have to go back and go through the note sheet just to complete the rest of this. So we have all of our words there, and so we are going to use those definitions as we go through. Now, can a particle be a single atom? Yes. Can a particle be a molecule? Yes. Atoms and molecules are representative particles, which means that it can be by itself or in a group, and we consider it to be its own particle. Over here, we wanted to circle the correct answer for each box below. Remember, pure substances are either elements that are all the same in the same space in a sample, or compounds, right? Now, in this case, it was a compound, a square and a circle element, whatever those might be. Those are 2 different that are chemically bonded, which means that is a compound. Now, that is the only thing that's in that space, which means each combination is the same as each other, so I have a pure substance. Same over here. Right? In this case, instead of a compound, it's an element, but they are all the same. In this case, they are not all the same. Not everything is exactly alike, which means it's a mixture. They are physically occupying the same space, and there are multiple pure substances in the same area. Same goes for this one, and then we have our pure substance there. Circle the correct answer for the box below in terms of our elements and compounds. Elements, remember, are one type of particle, or one type of atom that's inside there, right? Or compounds, where you have multiple elements that are chemically bonded together. In this case, those combinations consist of 2 or more different elements connected to each other, and so we say it's a compound. There's only one type of atom there, just the squares, which means that's an element. Same thing for the triangles here. We have our compound there, and we have compounds in here. All right. So coming down to this, now we can kind of differentiate between element, compound, and then molecule, right? Because a molecule can be either an element or a compound, right? And so we have to identify based off of the either particle drawing or the little formulas here, right? The symbols. So each element from the periodic table has its own symbol. It could be 1 or 2 letters, but that's how we can kind of identify, do we have more than one element in our formula? In this case, this is the capital A, lowercase l. There's 1 capital letter, which means it's an element, and it does not have a subscript, which means it is not a molecule. There's not a package deal. This one is H2O. How many capital letters? 2, which means it is a compound, right? 2 or more different elements that are chemically bonded together. And if it is a compound, then that means that it is a molecule as well, because it's a grouping. We'll talk about formula units versus molecular compounds a little bit later on. But for now, we just want to make sure that we know that anything more than 1 connected to each other will represent as a molecule. In this case, we have 4 capital letters, which means 4 different elements, which means it's a compound, right? 2 or more, and that also means it's a molecule. Potassium, K, that is by itself, that is an element, and it is not attached to anything else that's like it. So it is not a molecule. C and O, 2 elements, that is a compound, that is a molecule. And the last one, it is 1 capital letter, bromine, right? That is a symbol for bromine, so that is an element from our periodic table. But there's that 2. That subscript tells me that there's 2 of those attached to each other. Because it's more than 1 bonded, then we have a molecule. So that is how an element can also be a molecule as well. Now coming down here, again, I am going to do numbers 1, 2, 3, and 4, and then you can work through the rest and turn it in when you are done. Very, very similar to our activity with the paper clips. I have a little key up there that represents each element. And so how you're going to fill this out, you have your particle picture based on what the combination is. Remember, coefficients tell you how many of that combination there follows there are, and the subscript tells you how many of that element are in the combination together. And so in this case, we have 2 hydrogens is our combo, right? 2 hydrogen. And there's 4 of that combination, so I'm just going to draw it 2 more times or 3 more times, right? Is this an element compound mixture? Well, H is the only species there, right? The only type of atom, and therefore it will be an element. Number of atoms of each element, well, there's only H, and there's 8 of them, right? And so the total number of atoms is 8. Now the total number of molecules is 4 because it is the package. Each molecule has 2 atoms that are creating it. Going down here, we have nitrogen. Nitrogen has the 2 as a subscript, which means 2 are connected to each other. Oxygen has a 2 after it, which means 2 are connected, but that 3 in the front tells me that I need 3 of those groups to appear. And last but not least, CO2. That is 1 carbon that is also bonded to 2 oxygen. For simplicity's sake, we will just draw it out as it's written. Later on, we'll be talking about actual structures and what it might actually look like. In this case, is everything in here the same? No. And they are all different, but they're physically occupying the same space, which makes this a mixture. The number of atoms of each element, I see nitrogen, I see oxygen, and I see carbon. I count those up. I can do it based off of just looking here in the formula, or I can look at the circles that I drew for the particles. In this case, I have 2 nitrogen. I count up all the oxygen. I have 8, and I have 1 carbon, and the total there would be 11. How many molecules are there? All of those are compound, or not all of them are compounds, but all of them are groups, right? This is the only compound. This is an element because it's the same thing connected to itself. Same here, same for the other one, and same for nitrogen, right? And so it's a mixture of a couple of elements and a compound, but they are all molecules because they are all groups, right? They're all packages. Over here we have nitrogen. Nitrogen, and there's 2 of them based on the subscript, and it is connected to 4 oxygen. And the coefficient in the front tells me how many of that combination I need, right? And so I'm just gonna duplicate it, and there we go, right? This is not a mixture because the N2O4 compound is the only thing that's there. This is therefore a compound. I have nitrogen and oxygen. I have 4 nitrogen. I have 8 oxygen. Add them up. Total atoms are 12. The number of molecules, however, is 2, right? They're just long, big groups, 2 big molecules. And last but not least, C is the only part of this combination, and I'm going to have it 3 times. In terms of the nitrogen, it's going to be N2, so that means that there are 2 N's attached to each other, and the coefficient, or the large number in the front, tells me that there are 2 of that combination. Right? In this case, not everything in the box is the same, which means it's a mixture. You can also tell it's a mixture based on those addition signs there. I have in this carbons and nitrogens. I have 3 carbons. I have 4 nitrogens. That's a total of 7 total atoms. And now when we get to molecules, I would say that there are only 2 because these carbon atoms are not connected to anything, right? When they are by themselves, they are atoms. When they are grouped together, they are molecules. All right, so hopefully this gets you started on the rest of this chart. As always, if you have any questions, feel free to let me know.